Welcome, ladies and gentlemen, to our video review for the final. Now, you will notice on Classroom there are multiple reviews on there, so you can maybe see this once, then practice a couple of times on your own. I will have keys for those reviews online, copies of those reviews in class and online, but this is the only one I'm doing a video on. Okay, so work accordingly. Now, what we are going to do here is we are going to take a look at a few questions that are going to look exactly like the final. So put in your time, do your due diligence. This final should go pretty easily. First thing, what is the error in the work shown? What is the correct answer? Now, I'm going to answer these the opposite way. I'm going to start from the original. I'm going to work the problem out. Then I'm going to see where things got messed up. Now, you might do it the other way. I don't know. This is just me as a suggestion at the start. There are actually two ways to do this. I'm going to suggest at the start of this that you more than likely would be happier. Well, let's just do this. We're going to split this into two. Doing one video, let's go for the gusto here. So one of your options, and I have a feeling many of you would go this route, even though I think this is the trickier way. A lot of you, I think, would distribute. Now, why don't I like that? Well, let's see. That's not real nice. Okay, I don't want to keep going and going and going with fractions here. So if I did it that way, at this point, I want to get rid of all those fractions. So when I distribute the 5 here, the 5s would cancel with 1x. I distribute here, the 5s would cancel with minus 4. And over here, there's nothing to cancel. So 5 times 8 is 40. And actually, this ends up working pretty quick. Get x alone. Add my 4. Get 44. That works. What I personally would do on that question, so I'll put an or here, you do not have to do both when you see it on the final, is if I saw this, personally, I would multiply both sides right away by the 5. I wouldn't even do the distributing, because then the 5s just cancel. X minus 4 equals 40, and I'm already to where I was at over here. So either way, I get 44, which is the correct answer. So what happened over here? I'm like, well, it looks like they distributed too. Uh-oh. Okay. So here, they distributed incorrectly. Now, does that mean when we get to this question on the final, it's going to be distributed incorrectly? No, there could be another error. Maybe they distribute and then they add instead of subtract. Maybe they did a multiplication or division part wrong. But that's what we're looking for here. 2 parts. What'd they screw up? And then what's the right answer? Okay. So, what do you think would be the most common error in this problem? Okay, what's the correct solution? Again, I'd solve it first. We got to get all our x's to one side. I know for most of us that would be the left side. Got to get the x term alone once they're together. Again, great thing about these videos, if I get rolling a little too quick, you want to kind of look and pause things, you can pause me and then set me up again once I'm ready to go. Equals 2. Now, what do you think people might mess up? There's a couple of different legit answers here. Okay, one I would say right away would be minus 2x to both sides instead of plus. In other words, they just try to combine like terms. You're like, oh, 6x and negative 2x is 4x. I can't do that. Okay, so that would be a legit option. The other one that people tend to mess up or forget on this is they flip the inequality arrow around. Sometimes people move it to one side and then they just move the arrow accordingly with it, and you can't do that. So as long as you have an error that legitimately somebody could do, like you don't just write they done messed up or something like that, you'd be okay with that. Okay, you'd be okay. All right. Finally, just a straightforward normal one here. Solve and graph the following inequality. Show your answer in interval notation. Okay, so when we go to solve, when it's an absolute value, there's going to be two parts to this. First part, we just copied. Second part, we flip the arrow and change the answer side. So what I did in pink there. Once we've done that, go ahead and solve both of those. Now, one thing I'll be looking for, it's a minor thing, and it'd only be a small deduction, but it would be nonetheless. You've got to tell me, is this an and or an or statement? You're like, now how's that go again? And when we have and, those are the ones where the coloring comes in the middle. The ors are the ones that go out. So maybe you want to hold off on writing and or in if you're not sure until you've graphed this. Not a bad idea. So when we graph, let's see here. We want to count by the same thing each one. So I'm going to count by 4s. You could count by 2s. You could count by 1s. That'd be a lot to put in. And then basically follow the arrow, because when the arrow eats x, that's greater than. Greater than goes to the right. So x is greater than or equal to 4. Bracket. If it's not or equal to, it's parenthesis. Okay? Little things like that we want to be keeping track of. Again, if it's or equal to, bracket, greater than or less than is parenthesis. The little things just to be thinking about. Then x is less than or equal to, less than is left, -12. They're going out. This is an or. And so when I do interval notation then, because the story's got to be the same for all three of these, we go from left to right on our graph. Forever left until we get to -12. And since there's another piece, we have U for union, and then we start up again at 4, go off forever to the right. Okay? If it was an and, it would just be the two endpoints. It would almost look like a coordinate point. So again, work through, think through, try these on the other practices, see how they're going. Solve the following by square rooting. What do you think are the most common errors? Again, let's solve it first. We'll go from there. Opposite of the 72. Okay, that's not subtracting 4. We don't want to add 4 to both sides. We're multiplying by -4. So, we're going to divide both sides by -4. And remember, squared means there's 2 answers. And since 16 is a perfect square, we get the 4, and we're good. Okay? Golly, what do people forget? Let's give some examples here. Forget plus minus. Forget to break down the radical if they can. Like the one I talked about earlier, they add 4 instead of dividing by -4. any of those are legitimate things, okay? Because they're things I see all the time. So again, do you have to have them all? No, but get at least one good one in there, okay, for us to be able to work after that. All right, let's keep it rolling. Create a quadratic function shifted right 3 and down 2. Okay, right 3 down 2. Reminder, whoops, sorry about that. Left and right, up and down. Right 3, down 2. Most common errors. Guaranteed on this one. People think right, they think it's got to be positive. Okay. The other one would be they switch the right and down part around. They do this instead. Okay, either of those work. But again, those are things that we tend to miss sometimes. All right. Going to be able to tell Mr. Hardy put this one together. Mr. Hardy is selling barbecue pork and barbecue beef platters to raise money for new computers. On day 1, Mr. H sold 38 pork platters, 18 beef platters, and collected $650. Day 2, 29 pork, 22 beef, collected $620. What are the prices of the barbecue pork platters and barbecue beef platters? I'm hungry, man. This is lunchtime. What was I doing to myself? Define what your two variables represent. Be specific and accurate. Okay? So in my case, X. First thing I see, barbecued pork. So I'm going to make this barbecue pork platters, but not just barbecue pork platters. You're like, no. Now let's see here for a minute. First inclination would be, do I want to put, number up? But I know how many I sold. But I don't know how much each of them cost. Because it says that right here. What are the prices of those? I need to get that in. You could say price, you could say cost. My other one is the barbecue beef platter. Again, cost. Got to get that in there. So then when I go to make my equations, when we did this before, we said, where's the first sentence that has numbers? And just start underlining. 38 pork plus 18 beef equals how much I have. And I find the other sentence with numbers. 29 pork plus 22 beef equals 620. You do not have to solve, just set them up. Variable setup, system setup, we're good to go. Still rolling. State the domain and range. Determine whether it's a function. Okay, domain. X values. Left to right. There are no arrows. Now, if you get arrows, what do arrows mean? Arrows mean infinity, but there's no arrows this time. So, furthest left, follow it back to the x-axis. To the right, follow it back to the x-axis. Range, y values. Bottom to top. Bottom, here's my lowest one. Y value. 5. To top. Y value. 2. And then determine whether it's a function. Well, how do I know that again? Okay. The vertical line test. Remember, we go through and we see if it's only crossing at any point. It's just crossing one point in here. And if it's only crossing one point, then it's a function. Line test. 1 point only. No matter where I got it, there's only 1 point that's going through. Now, if my graph would have been, let's say, this way, and I'd have been going, oh, well, now it's going through more than one place when I have my vertical line, then it'd be no. Okay, but if it only goes through my vertical line 1 point at any time all the way across, we're good. All right. Oh, calculator time. All right. Katniss shoots an arrow upward. The height is given by the equation. Complete the table to show the heights. Okay, here's all we're going to do here. Get my y equals set. Negative 16x squared, because my calculator doesn't like if I use t. So I hit my graph at first, because that's what we normally do, right? And at first I'm like, well, what am I supposed to be doing? Oh, time is x, height is y. So they want me to take these x values, which I can get by looking at my table, second graph. Going down to 2, that's my x value, and just copying my y. Go down to my 3 value, copy my y. Go down to my 4, copy my y. Then it says, determine when the arrow will hit the ground. Where's the x-intercept? So, go back to second trace. Number 2, I want the 0. I want that. So just like we did before, we're going to use just our right and left arrows. So since this is here and I need to get over here, I'm going to hit the right arrow until it comes over here. So it may take me a minute, and that's okay. Okay, get as close as I can to the intercept. Get to x-intercept. Then we're going to do 3 left, 2, 3, enter. And then we're going to do 6 right. And you're like, now why 6 again? 1, 2, 3 gets me back where I started. And 1, 2, 3 more. And enter twice. Once to set the bound. And once for my guess. And the x value is how long it's going to take. Now, given forewarning on this. We're going to be allowed to use the factoring help sheet. That's going to be it, though. So you've got to know your button presses. You've got to practice, and you've got a couple more reviews to do that with. All right, graph the following function. Try it without a calculator. Wow, how would I do this without a calculator? Remember, left, right, up, down, but it also tells me my vertex. Opposite of h. And k to -4. Put my vertex, and then we have a value in front of 1, which is my slope. So it just means go up 1 and over 1, each direction. Up 1 and over 1, each direction to make my v. Now, if I forget, okay, you don't have to do it without the calculator. So you're like, well, how do I get the absolute value again? And how do I get that glare off of there? There we go. If you need absolute value, okay, is math over to num and number 1. X minus 2 minus 4. And I can pull the graph that way. And then I would just hit second graph. I'd get my vertex in the middle. There's my symmetry. And I would just use the points out of here. But again, if you're going to do this, you need to know that because we don't have that somewhere. And I'm not writing it down somewhere. We just got to work through. Okay? Getting there, though. Rewrite the following by solving for D. Okay? Got to get all the D's together first. Now, once I get the D's together, D cannot be part of my answer. Okay? So I can't just, like on this other one, divide by 4 and call it good. That won't work. These both have a D, right? They have something in common. We've been talking about that a lot with factoring. Pull the D out. Okay, if I divide each of these by D, D's cancel. I'm left with 4. D's cancel. I'm left with minus R. And look at what I got. I got 1 D left. Sweet. So to solve for it, I just got to do the opposite of this. I'm multiplying D times this. I do the opposite. D's by itself, I'm good. Okay, got to play the factoring game. We are getting near the end here. Getting near the end. Circle the two expressions that are equivalent to this. You're like, okay, so how's this going to work? Basically, I got to jump in and I got to start simplifying these until I find a couple that equal this. So I look, I'm like, okay, well, 9 over 6. Let's start with that. 9 divided by 6, math, enter, is 3 over 2. Wait a minute. 3 over 2 isn't 2 over 3. Okay, it's not that one. As soon as you know it's not that one, don't keep doing it. Here, what do negative exponents do? They flip stuff. So I'm like, okay, so I flip 2x to the 4th to the top. I flip 3y to the 3rd to the bottom. I'm looking at this, I'm like, maybe on this one. But then I remember, wait a minute. I distribute that 4 through. I distribute that 3 through. Same thing? Nope. Okay, not this one. So 2 out of these 3 are going to work. So let's see here. Negative 1. This just means it flips this whole thing. Okay, this is going to flip up. This is going to flip down. Yup, that one works. This one. All right, let's see here. Well, now we're going to know at the end what's up here no matter what. 12 is 2 over 3. Okay, so far we're good. What's the rule when we're dealing with exponents? You subtract them. 6 minus 2 is 4. X to the 4. Uh-oh. Nope, not supposed to be on the bottom. It's supposed to be on the top. Just by elimination, it has to be that one. It's a strategy. It's a strategy. So 2 of those work. Factoring, you knew we were going to have factoring, right? You knew it wasn't going away. So factoring, all right, let's see. What do we know? Multiply numbers negative, one of each sign. Add numbers positive, the positive number is going to be bigger. So I go to my calculator and I start dividing numbers into 22. But I need a pair that can help me get to 9 somehow. Well, 1 and 22 ain't doing that. Ooh, 2 and 11 count. Sign of the bigger number. Bang. Same idea on the second one. This time my multiply number is positive, which means they're either both positive or they're both negative. How do I know? Sign in the middle. And I do the same thing. I go to my multiplication chart. I go to my calculator. And I start dividing numbers in and making myself a list. Now, after a while, I'll stop because I probably didn't even need all these. Can 1 and 36 get me to 15? Nope. Can 2 and 18 get me to 15? Nope. Can 3 and 12 get me to 15? Yes. Yes, it can. And I'm good. Now we get down to here and we're like, hey, look at that. We just saw this recently. The electrical circuits are back. But we remember that all we needed to keep track of on this is that this is R, this is Li, this is Ci. The formula's right there. I just have to follow. So seriously, all I'm doing is R plus L minus C. 8 plus 4 is 12, minus 3 is 9. Keep it simple. Don't let the words mess with you, okay? Just keep the labels and roll. And to wrap up, ladies and gentlemen, our post-test preview. Which method would you choose for solving the following system? You're like, okay, what choices do I have? We have substitution. Okay, we use that if there's x equals or y equals in one of the equations, but I don't see just x or y equals. So this one doesn't look like substitution. Elimination occurs if we happen to see something maybe where we could add down and get something to go away. So here, if I look, 3x minus 3x, if I add down, cancels. That's what I want. 4 and negative 9 is negative 5. 10 plus 15 is 25. Divide by negative 5. We've got y. Now you're not done. You're not done. We still got to know what x is. So what do I do to find x? I pick either one of the equations. I usually just use the top one. And we're going to use substitution. Every place, oops, sorry, that's x. Every place I see a y, I replace with the y value. And then I'm going to solve for what's left. 4 times negative 5 is negative 20. And we're back to Algebra 1 stuff. Go ahead, divide that out. X equals 10, y equals negative 5. Method, elimination. Y. No x equals or y equals. That's going to make it a little bit simpler. Okay? So again, there are 3 of these in total. We walked through this one. There's 2 others that I have handed out to you in class and that I have online where there are keys. This one, there's a video. If you need to have the video while you're running one of the other ones maybe to try, you can. But put in the practice and you should have a good success rate with this. We'll see you next time.